Hello everybody and welcome to Sigma-HSE's monthly webinar. Hopefully you'll find it interesting. This month we're going to talk about incident and near-hit investigation methods. Okay, just to introduce myself, some of you will have heard me before on these webinars. I'm the Technical and Operations Director over here in Winchester in the UK, and you can see from my short biog there that history in the chemical manufacturing industry, then also as a regulator in the UK's health and safety executive, and then for the past 18 years or so in process safety consultancy. So over 40 years in process safety now in one way, shape or another. So hopefully I should know a little bit by now. In terms of Sigma-HSE, I mean, we're a global company with offices in the US, in New Hampshire, headquartered in Winchester, and in New Delhi in India, where we provide our offerings to clients who'd like us to work with them. But we've also got the luxury, both in the UK and in India, of process safety laboratories. So we're able to really probe by undertaking testing of anything that's capable of fires or explosions or as tricky electrostatic problems. So as a process safety consultancy, as well as the laboratories, we do everything you'd expect a process safety consultancy to do. From the consultant point of view, whether that's helping companies develop process safety management systems from scratch, or developing some of the elements of process safety, like incident investigation, methodologies like management of change, like asset integrity management, all of these good stuff. And we spend a lot of our time undertaking various risk assessments, HAZOPs, LOPAs, hazards, and many other things like that. So well skilled to be able to help you. Now I'm just going to introduce this topic a bit, but first of all I'll introduce you to Doug, who's one of our senior process safety consultants over in the States. Doug will be the person who takes you through the methodologies for this webinar. So please introduce yourself, Doug.
Thank you, Andy. Yeah, my name's Doug Gruder. I have 28 years of experience in plant operations, EHS, and process safety. You can see some of the areas that I've worked in: process control, operations, and a number of years doing process safety studies, different kinds of PHAs, and getting those results out to internal and external customers. I'm going to pass it back to Andy now to speak a little about the evolution of incident investigations.
Yeah, thanks, Doug. I just wanted really to set the scene as to why undertaking incident investigations of incidents, and importantly near hits, is critical to an organisation. And where near hits are considered, although by definition nothing really bad has happened in a near hit, but it has a level of potential, and obviously dependent on the level of the potential determines really how much effort goes into the investigation of that near miss. So one of the first things when you get a near miss report is, okay, it's a near miss, but if it happened, what would happen? You know, what's the potential? What would happen if that near hit became an incident? Yeah. So if we could blow the whole plant up, if we didn't improve this near hit or fix this near hit, then obviously you can see why in that case you take an in-depth investigation of a near hit, not alone, not just an incident itself. Now, near incident and near hit investigations is a key element of the process safety frameworks that are out there, either the Centre for Chemical Process Safety guidelines in the US or the Energy Institute equivalent in the UK. There's other ones around as well. But incident investigation is one of those key elements, and it's It's housed under one of the pillars, the learning pillar, how the organisation learns and proactively manages improvement. Yeah, so it's really important. Now, you know, I'm old enough, I can go back. This wasn't always the case. We didn't always do what is expected of organisations to do incident and near hit incident investigations as we expect them to happen now. Yeah, I'm due to retire at the end of this month after 44 years in the major hazard industries. But when I started back in the 1980s, it was common in investigations to stop when we got to the causal event. Yeah, the plant blew up because an operator forgot to close a manual valve. Just like the Danvers event that happened in the States a few years ago, where during the manufacture of flammable inks, the process blew up overnight, causing lots of off-site impact. Now, in the olden days, once we found that an operator hadn't closed that manual steam valve that overheated the flammable liquids, then this generally resulted in one of three things happening to that operator. Two if we liked the operator and one if we didn't. If we didn't like them, we fired them. And if we did like them, we either promoted them or we sent them on a training course. Now remember, the whole idea of doing investigations is to prevent the event happening again. We hear it all the time in the news. We need to learn the lessons. But you, I'm sure, hopefully you'll agree with me, as humans, we're not very good at learning lessons. We need to get better. Yeah. But, you know, if we fire, granted, if we fire or we promote the operator that didn't close that valve, yes, it stops them from ever having to close that manual valve again. It's no longer part of their job. But if it still remains a manual valve, some other person will still have to operate that valve. Yeah, and it may have been the case at Danvers that quite diligently the operator set off to close that manual valve. But on his way, his manager or another colleague caught up with him and started up a discussion. Might have been work related, might have been about the football match the night before. Doesn't really matter. But at the end of that discussion, the operator turns back, and for all intents and purposes, that operator thinks he's closed the valve. In the investigation, of course, we find that that's not the case. Yeah, but we're all humans, and every one of us, you know, has this effect. So the third thing of sending them on a training course, I don't know of any training course that teaches you not to forget things or to be distracted or anything like this. We've all done it and we'll continue to do it. So this is why investigations these days, it's all around trying to find what's called the root cause. Finding the root cause is paramount. And Doug will take you through this in a few minutes. But you're sort of asking the questions, you know, we've got a manual valve and somebody forgot to close it. But what happened during the design process? That we ended up with a process where this critical manual valve, if it was left open, could result in the plant blowing up. What happened during any of the risk assessment processes that we did, or hazard identification methodologies used? HAZOP. Why didn't we pick this up then? Yeah, most companies now will do what's called process hazard reviews quite frequently. Why have we not picked up this critical element? We'll have had auditors on the site specifically looking for problems. Why haven't we picked all that up? So enough said really. I just wanted to get the point across that without delving into the root causes and fixing the root causes, will we ever be in the situation of improvement and avoiding the same event happening again? So at that, I'll stop talking now till the end, and I'll pass over back to Doug, who'll take you through how to do a proper near hit and incident investigation. Over to
Thank
you,
you,
Doug.
and welcome everybody to the webinar. So the purpose of this introductory course, and it will not result in you being an expert on incident investigations or near hits, but is just to provide some basic training and what we look for when we're doing these investigations. We're going to talk a little bit about evidence gathering and some tools that are used in the ECF methodology. Some about causal factors, driving down from the causal factors to the root causes. And hopefully this will improve the quality of our investigations and drive down to the root causes, which are always management system failures, and putting recommendations in place to prevent the events from ever occurring again. So why do we investigate these events? Well, we don't want it to happen again, certainly. We want to identify what has failed in the process safety management system and why it failed. We want to identify anything that may be missing, and we want to learn from our mistakes. In addition, what are we investigating? Well, we're investigating the causes of the release of energy, flammables, combustibles, toxic materials, the causes of them, and the failures in the management system that can be corrected to prevent them from reoccurring. We also want to be aware that we should lower the risk of a repeat event before we restart the process. I know everybody is familiar with the safety triangle, but things kind of build up. So you may be living with unsafe acts and conditions for a while. They may not cause any events, but you'll start having some near hits. And those near hits over time, if the root cause is not identified and fixed, will result in non-lost time events, lost time events, and God forbid, fatalities. So every incident investigation technique has a framework. And we use this framework to interpret what happened and how to prevent recurrence. The typical framework will recognize that an incident or a near hit involves a chain of events. That chain of events has to do with a deficiency in the process safety management system and can be part of either a poor design in the beginning, an engineering control that did not work, and the least effective is administrative controls, and we'll look at that a little bit more. We should be aware that events represent not only one failure, but many parts of the management system could have failed, which result in the near hit or the incident. So don't just end your investigation when you find one thing wrong with the management system. Look a little harder and identify what else may have went wrong. So the process for all incident investigations are, first you put a team together, okay? Then we gather the evidence. The evidence should be gathered when the scene is safe, okay? But as soon as possible, so that things don't get changed around. You don't want to go into a scene and start gathering evidence when there's still a risk in that area. But you do want to get there soon enough so that you can preserve the site. We want to construct a sequence of events, and there'll be a lot of hypothesis going around about why it happened, but we really want to get to the root cause of why it happened. We want to look at conditions around the events and analyze the data to determine failures of the management system. And we do that by identifying causal factors. From the causal factors, we want to drive down. We can use a 5 why technique to drive down from causal factors to the root causes. After we identify the root causes, we want to identify recommendations that will fix what was deficient in the management system. So every morning when we wake up, we're surrounded by a number of hazards. Those hazards need to be controlled. Even if it's just driving your car to work, you want to make sure that your brakes work and your directional signals work and everything in the car is operating as it should be. So there are a couple of different layers that we have to control hazards. Equipment design is the most important, the strongest, but it doesn't eliminate all of the hazards. So we have to add some more layers of protection. They should be independent layers of protection. Let's say engineering controls. That's your control system running your process to maintain a certain pressure, temperature. Now we get to some of the weakest areas of control that we have, but they're still very important, are administrative controls. Some of our administrative controls may include PPE, personal protection equipment, also personnel. Do you have the right people running the process? Are they trained? Do they know the dangers, and are they aware? What's their mindset during that day? Are they distracted by something going on at home, or are they fully aware and involved with what they're doing? As previously said, an event represents a failure of one or more threads, or a thread that's missing that we never even thought to put in. Multiple failures in the system can lead to a chain of events. The safety system should be designed with as many ways of interrupting that chain of events as possible. You take out one of the links in that chain of events and you prevent the event from happening. Some factors that affect the net can be management of change. Was the change looked at for potential hazards? Has the equipment decayed or changed? And this is part of your mechanical integrity program, as well as calibration of instruments and control systems. Another one that sometimes is overlooked is our personal attitudes. Okay, so does the operator or mechanic doing a job have something going on at home? Maybe they didn't get a good night's sleep. Maybe they had a baby crying. Any number of things. But you want to make sure that your employees are fit for the duties that they're doing. I'm sure everybody is familiar with the safety triangle. For every single major injury, there are 10 minors, 30 property damage, 600 near hits. So these events build on each other until you have a lost time injury. There are clues, and that's why near hits need to be studied, because you want to prevent whatever's going on before you get up to a disabling major injury. So how do we identify potential causes? Why did the event happen? Keeping in mind that all events are the result of a management system failure. But we have to identify which pieces of that management system failed. And you're going to hear this over and over throughout the presentation. Which pieces of the management system failed is what needs to be determined. The failure of a management system is always the root cause. So if you haven't come down to something that can be changed by the company or the management, you're not at the root cause yet. And they can be the engineering design and administrative control, such as PPE, or the people. So we want to look at the differences or the gaps. Doing an investigation, we should always ask several questions. What happened? Why did it happen? And what failed in the management system that we need to correct? In the events and causal factors approach, we start out by putting together a timeline, a sequence of events leading up to the incident or near hit. Then we want to drive down to ask why it happened. And finally, what was the management system failure that allowed it to happen? Looking at this triangle with an example, we have we have an operation of a safety device, say pressure safety valve lifts, relieving pressure to a safe location. Why did the column pressure get too high that resulted in this overpressure of the column? Was the SOP inadequate, or was the operator not trained in the SOP? Did the operator start taking unauthorized shortcuts because something in the system made it hard for them to do the task? So all of these things may not have been taken into account when designing the system. We're going to talk a little bit about ECF charting. So some basic concepts here is you would put in a circle the event, the reason that you're doing the investigation. The sequence of events would be put in to rectangles, and that's what happened leading up to the investigation. You also want to add some conditions, other things you know about the system in ovals. From that, you'll determine a causal factor. Keep in mind that the causal factor is not the root cause. In the example given previously, an operator left a valve open. That would be a causal factor. We don't correct the situation by getting rid of the operator or blaming somebody, but we drive down. 5Y is a good way to get down from the causal factor to the root cause, to identify the management system failure that led to the causal factor. And that's what we want to put recommendations in to prevent going forward. So like I said, we build a sequence of events leading up to what we're investigating. And we do it sequentially. You know, we just put what happened going along, what happened next, what happened next. We get to the incident or the near hit that we're investigating. And then after that, we do what was the response? What was the emergency response team, the emergency action plan that should have happened or did happen, and how can that be improved going forward? We're going to go into causal factors now. We should always ask two questions of the conditions. Can we manage or change the conditions? And would removal of that condition prevent the event from happening or lessen the severity? If the answer to those two questions is no, we have not identified a causal factor. If it is yes, label the condition, and then we drive down to the root cause from there. Some examples of different causal factors which you may encounter are equipment. You should consider the conditions and add to the chart if applicable. The failure mode, the design, the conditions before, during, and after the event. What were the temperature, pressure, flow? The status of the instruments. Were there any alarms that worked or did not work? Were there any interlocks that could have activated that failed to activate. We want to take a good look at these, as these are your strongest independent protection layers. Another category we look at are people. Do they have adequate standard operating procedures? What were they doing? What were they thinking about at the time of the incident? Were they trained, tested? What's the relative position to the equipment if somebody was injured? Were they in the line of fire? Was their supervision adequate? Was there a breakdown in communication on what was supposed to have been done? And fitness for duty. What was the state of mind of the employee? Did we not catch that the employee was tired? Maybe was up watching a football game all night? Was there any PPE used? And was it suitable for the task? So these are some things we want to be looking at. Another causal factor could be environment. Was the area lit? Was it noisy? Was housekeeping poor that resulted in a slip and a fall? So all of these things could be contributing causal factors. But remember, we don't stop at the causal factor anymore. We drive this down to identify the root cause. And what is a root cause? It's a management system failure that can be fixed and controlled. How do we get to the root cause? We ask a series of why, the 5 why, regarding the basic cause of the causal factor. Why did the management system component not function at the time? And we have to keep in mind that there are usually numerous root causes, and we should not just stop at one root cause without investigating further. A root cause is a subdivision of a basic cause category. Okay. Generally, it includes something is not there or missing, such as training. It's not used or followed, like your MOC system. It was just wrong or incorrect. Equipment design, construction, procedures. It also is probably insufficient or inadequate. Maybe it wasn't covered in a PHA. But there are multiple levels of subdivision and classifications that are possible. A very simple effects and causal factor chart is this example where a person walking to their car in the parking lot steps in a hole, twists and sprains their ankle. And then the person has to go to the hospital to get treated. Some of the conditions may have been that it was an unusual parking spot, unauthorized parking. There were no barricades or markings for the hole. The parking lot was poorly lit, and maybe the person worked late and was walking in the dark. From those, you'll identify the causal factors and then drive down to the root cause. So in summary, all events are the result of management system failure. To identify the management system failure, we first develop a timeline, identify the causal factors, then drive down from the causal factors using a 5 why approach till we get to the management system failure. We then put recommendations in to mitigate or fix that management system failure to prevent a similar event from ever occurring. Now I'll turn this presentation back over for questions.
Okay, so thanks, Doug, for that very interesting little webinar on an important subject. Now is your chance, people. If you've got any questions on that, then just drop them into the question box on the system or the chat box, and we'll pick those up. If you've got any from, burning questions from what Doug or I have said. If not, and you think of something overnight, you can always drop us an email or give us a call, and the numbers and email address are on this slide. There is one question that's just come through. It says, how soon should we start gathering evidence? Do you take that one, Doug?
Sure. Should start gathering evidence as soon as it is safe to do. You don't want the event area to change too much, but you don't want to go in and start collecting evidence if it's going to put you or another person at risk. So as soon as safely possible, evidence should be gathered.
What about if there's any regulatory, if it's a serious incident, there'll be regulators come knocking at the door?
Well, if regulators come knocking at the door, and this would be a very serious incident, like you said, should be open and honest with them. Should also make sure that it's safe for them to review the site. So you don't want to put anybody at risk by bringing them into the event area if there are still unsafe conditions there. But always be open and honest with regulators.
Yeah.
And
sometimes it's difficult. I remember one case in the UK a few years ago now, where they were dismantling a power station, and the power station collapsed, and there was half a dozen people killed. So it was a serious event. And one of the biggest problems there, obviously it went under a regulator investigation, but one of the biggest problems was, of course, the families of the people who'd been killed, because unfortunately, because they had to make that safe, the bodies were left for quite a significant period of time before they were able to recover them, unfortunately, because it just wasn't safe. It was something to do with that the system had some sort of spring-loaded system that collapsed, and it was thought that not all of it had collapsed, so the same thing could happen again if they went in and started moving things. So there was an awful lot of assessment of the hazards and risks that went on before the investigation could start. So that's one instance. Another instance that comes to my mind is you know, why as a company, if you want to carry out an investigation, why you need to do the gathering the evidence as soon as possible is because, of course, evidence can change. People can have a different view of things after they've been in the bar overnight, what have you, and they talked with each other and things like this. And what you're after really is facts, not perceptions and things like this that can muddy the water. And of course, the longer the gap between starting the investigation and asking the questions and gaining that evidence, the more likely it is that the facts will change. Oh, we've got another question that's come in. It says, is it standard practice to stop at 5Y?
Yeah, five whys can help you drive down from the causal factor to the root cause. But you have to make sure that you have the sequence of events lined out first, because there almost certainly will be more than one root cause. And if you don't put the timeline together, you may miss an important causal factor and the subsequent root cause for that was in the chain of events. Sometimes breaking that one link in the chain of events can prevent the incident or near hit from happening.
I mean, one important thing to recognize with the 5Y technique is lots of people think you have to ask why 5 times. And the reason why it's 5 times is, generally speaking, on the whole, by the time you've got to the 5th why, you've got down to the definitive view, and that's the end. But of course, that's not always the case. Sometimes you can get to that definitive cause after asking why twice, and other times it may take 8 times before you ask why. It's just diligently keep asking why until you get to the definitive end. So it could be 5 whys, 8 whys, it could be 24 whys, it doesn't matter. The technique is just applying the word why. You've got a statement, well, why? Why did that happen? Well, because of this. Well, why did that happen? Until you get down to the end where asking why, there's no reason to ask why. So it doesn't really matter how many whys you ask, it's just you keep asking why until. But as I say, it is misunderstood, and people think, you know, I've been in incident reviews where we've got to 3 whys, but well, it's a 5 why technique, we've got to think of 2 more whys. That's not the case. Or on the converse, we've got to the 5th why, that's the job done. Again, that's not right. It's when you get down to the correct point. You keep asking why until you get down to the correct point, the answer basically. Okay, so there's no further questions come through, so we'll end the webinar at this point. Thank you very much for taking part and listening to us. I'll repeat again that if you think of a burning question overnight or when you're having your breakfast in the morning, feel free to send us an email or pick up the phone. And if you require any help, if you're in a company that's just started on developing an incident and near hit system, or you're busy in an investigation and you're a little bit stuck, then just give us a bell and I'm sure we can help. We'll charge you, of course, for that honour, but you know, we all have to keep the wolf from the door. So on that, I'll say thank you very much and goodbye.
Yep. Thank you, everyone. Have a great day.